Well, hello. This is odd to be teaching you from my kitchen counter, but here we go. We're going to try this out. I'm just going to do a quick review of the parabola that we had discussed in class, and we had the two different forms, and I messed up calling that vertex. We had the standard form and the general form. And so standard form gave us the y equals a times x minus h quantity squared plus k, or x equals a times y minus h quantity squared plus k. And then the general form gave us y equals a x squared plus bx plus c, or x equals a y squared plus by plus c. We are going to deal with this form as we talk about the anatomy of the parabola. So remember, when we are stretching and shrinking horizontally, we look at this coefficient here, and that tells us the vertical stretch and shrink. So the vertical and the horizontal are perpendicular to each other. So your horizontal will be a stretch of 1 over a. So that makes this distance from here to here, or from here to here, half of that. So 1 over 2a. And remember, we did our paper folding, and so we found that the set of all points P in a plane that are the same distance from a given point, that was this guy here, and a given line. So that was this dotted line here. So the set of all points that are the same distance from a given point in a given line. So this is the set of all of those points that are the same distance from this point here and this line here. So if we're saying that from this point over to the parabola is 1 over 2a, then from this point to the line, the dotted line, is also going to be 1 over 2a. This point here is also the same distance from the point as it is from the line. So this distance is 1 over 2a, which means that these distances are half of 1 over 2a, or 1 over 4a. So we've got some distances set up there. That will help us with the coordinates. We know from doing parent functions and shifting that h and k give us our horizontal and vertical shifts. So this guy right here, called the vertex, his coordinates are negative h, k. Then this point up here, called the focus, has the same x-coordinate, so negative h, but the y-coordinate has been moved up by 1 over 4a. So we have k plus 1 over 4a. This line down here is in the same axis, the same y-axis. And so the same x-axis. So the y is what we're looking at. So this y value, k, has been decreased by 1 over 4a. This is all a constant, right? K is a constant, 1 over 4a is a constant. So this will just become a constant, a y equals constant. And this line is called the directrix. All right, so let's talk about this line up here. So it has a distance of 1 over a, and this line is perpendicular to this axis here. This axis here is called the axis of symmetry. That was something that you learned in Algebra 1. So I'm just going to put a little box around that. Axis of symmetry, and it has the coordinate x equals -h. This line here, though, is perpendicular to the axis of symmetry. His name is the latus rectum. All right. The latus rectum. So that's this entire line here. It's perpendicular to the axis of symmetry, and then it hits the parabola. Its endpoints are on the parabola. So these coordinates here will have the same k value as the focus. So k plus 1 over 4a, and this one will have k plus 1 over 4a. But the h has been moved. The h has been moved over an amount of 1 over 2a. So this h will be added, -h plus 1 over 2a. This h, -h minus 1 over 2a. So those are our coordinates for the endpoints of the latus rectum. And that's the anatomy. So that was the review from our previous class. We also talked about circles. And just to give you, actually I'll give you another video on circles.